Today's video is on independent and dependent events. And again, this is all probability stuff. Um, Pretty simple. Independent, we know what independent means. It means you're kind of on your own. And so when we're talking about independent events, what that means is we're talking about multiple events. And if they're independent, it means the first event has no effect on the second event. Whatever happens the first time, it doesn't matter for the second thing you're going to do. So a very simple example of this is if I were to roll a die and then flip a coin. When I roll the die, I can get any 1, 2, 3, 4, 5, 6, doesn't matter. And it makes no difference what happens on there. That's not going to affect how the coin flips. The coin is still going to flip the same way, and I'm still going to have either a heads or tails that I could get. And so those are completely independent events. Now dependent, obviously dependent, you depend on something. Dependent events, the first event does affect the second event. A simple example of this is like if you're pulling something out of a bag, like pulling marbles out of a bag. If I have 15 marbles in the bag, and I pull when they're different colors, I pull one out. If I leave it out, now I've only got 14 marbles left in the bag. So I've changed the probability of what I can pick because I've changed the total number of outcomes. I could have also changed the number of outcomes for a certain color, depending on what I pulled out. And so that one, the first event, does have an effect on the second, so those are dependent events. Now, I can find the probability of both independent and dependent. So we do a couple examples here. So this first one, we want the probability of rolling a 5 on a die and then flipping a coin and getting heads. So what I'm going to do first is just find each of those probabilities independently. So the probability of rolling a 5, there's only one 5 on the die, so that's a 1/6. And then the second part is flipping a coin and getting heads. Well, when I flip a coin, there's only two choices, and one of them is heads, so it's 1 out of 2, or 1/2 for the probability of flipping the coin. So if I want to know the probability of both those things happening, it's kind of like the fundamental counting principle. Okay? That has a lot to do with this. Fundamental accounting principle said if I had 6 ways to do the first thing and 2 ways to do the second, there were 12 total ways to do it. Well, similarly, if the probability of the first is 1/6, the probability of the second is 1/2, the probability that both will happen is just the answer you get when you multiply those two probabilities. So in other words, in this case, I multiply it. 1 times 1 is 1. 6 times 2 is 12. And so the probability of rolling a 5 and then flipping a heads on a coin is 1 out of 12. There's 6 possibilities when I roll the die. There's 2 possibilities when I flip a coin, so there's 12 different outcomes altogether. There's my bottom. There's only one way I can get a 5 and get a head. I have to get a 5 and then flip head. There's only one way that can happen. So probability is 1/12. But that's the important thing to remember here is you're multiplying these probabilities together. It works the same way for dependent events. Okay? So I've got a box. It's got 5 pens, 7 pencils, 3 markers, and I'm going to draw out of this box 2 items. And I want to know the probability that I pick a pencil the first time and then leaving it out of the box, picking a marker and I don't look either time. So the first thing I need to do is find the probability that I pick a pencil the first time. So my favorable outcomes is how many pencils, which is 7. My total outcomes is the total number of items in the box. So I've got 5 and 7 is 12, and another 3 makes 15. So I have a probability of 7/15 of pulling the pencil out the first time. Now I want to know if I leave that pencil out of the box, what's the probability I'm going to pick a marker the next time? Well, if I leave that out, then there's only 14 things left in the box. And now I want to know the probability that I pick a marker. And so I have to assume the first time I did get one of the pencils. If I didn't, this doesn't work. So I've got to assume that, yeah, I did get a pencil the first time, so there's still 3 markers left in there. And so the probability of getting a marker the second time is 3 out of 14. And then again, I want the probability that both those things happen. I'm going to multiply the two together. And I notice right away I can reduce these. 7 and 14 I can reduce. The 14 would become a 2, 7 goes in twice, 7 becomes a 1. And then the 3 and 15 I can also reduce. So the 3 is going to become a 1, and the 15, 3 goes into 15 5 times. Then I'll go ahead and multiply. 1 by 1 is just 1, 5 by 2 is 10. And so the probability that I'm going to pick a pencil the first time and then a marker the second time is 1/10. And so that's how you use dependent and independent events. It's the same idea both times. Find the first probability, find the second probability, and multiply them. What you need to be careful about is when you're doing especially dependent events, that you're really careful about what the new numerator is going to be and what the new denominator is going to be. Okay? You always assume that the first event does happen. So if I had asked, what's the probability of picking 2 pencils, the first time would have been 7 out of 15. The second time I would have assumed one of those pencils was gone, so I would have 6 left out of the 14 left in there. So it's really important that second probability, especially in the dependent events, that you have your favorable outcomes and your total outcomes correct. But both cases, you just have to multiply the probabilities to get your total probability.